Hello. In the last couple of lessons, or last 2-3 lessons rather, I went in detail over the compound angles. I have listed the formula there. But then we extend the concept of compound angles to another topic. It's called the double angle formula. We did compound angles. Now we are doing double angle formula. Alright? What is this double angle formula? To understand this, what is sine 2 theta or sine 2a? Okay? But we know the formula for sine of a plus b. Oh, by the way, I am Sosale Mohana. I'm a maths teacher with considerable experience of teaching A-level maths. So I'm just going over some of the topics to help you revise or help you go over what your teachers have taught you. So now, double angle means we're talking of ratios of 2 theta. These formulae are very, very, very important when we do integration, polar coordinate, for the maths, everywhere obviously, but for you, integration and differentiation, parametric equations. So, suppose I have the formula sine of a plus b is sine a cos b plus cos a sine b. Very good. I hope you have done what I told you on a sheet of paper or your memory card. You wrote all the other formulae I gave in the past so many lessons on trig. Then you added these. You're going to add more. I want to get 2 theta. When can I get 2 here? If A is theta, B is theta, that becomes 2 theta. So A equal to B. Should I use 2 theta? A equal to B, that's enough for us. So I get sine of A plus A is sine A cos A plus cos A sine A. In other words, sine 2A is 2 sine A cos A. Okay? Well, so I will rub these now. These are in my memory, the sheet or the memory card is inserted here. So I remember it. And I can close my eyes and I can see the formula. So you now start adding on to your memory sheet. Remember, all this formula you should know, but I will show you tricks later how you can exploit the formula book to get these. So therefore, I can say here, this pen. I can say here sine of 2a. So these are called double angle formula. They are not in the Edexcel formula book. I don't think they are in any formula book. You can deduce them. So first formula I got was sine 2a equal to 2 sine a cos a. I'm sticking to a instead of theta. Alright? Now, I told you we mathematicians are very fair people. Meaning, if I do sine, I must do cos. If I do cos, I must do tan. Otherwise, I'm not being fair to the other two. So let's rub this off. And then, I'm trying to save space. You can't do this in the exam. Oh yeah. So now, what is cos of a plus b formula? Is cos a cos b minus sine a sine b, correct? Very good. So suppose I put a equal to b. What do I get? cos 2a equal to cos a times cos a is cos squared a, sin a times sin a is sin squared a. So I have one formula here, cos 2a equal to cos squared a minus sin squared a. Very good formula. I think I need a new pen. Therefore, but remember we proved that sin squared a plus cos squared a is 1. Remember that formula? So therefore I can say cos 2a as cos squared a minus 1 minus cos squared a, which is cos squared a minus 1 plus cos squared a, which is 2 cos squared a minus 1. So I have cos 2a equal to 2 cos squared a minus 1. I told you we are very fair people. If I have got cos 2a in terms of cos squared, why can't I get cos 2a in terms of sin squared? Fine. Let's go back here. The same formula, I can write cos squared a as 1 minus sin squared a. One minus 2 sin squared a. Please, you might be wondering, why can't you just leave it as cos squared a minus sin squared a, sir? Or Mr. Mahana, why are you wasting your time? I'm not. I'll explain shortly where these become useful. Okay. In other words, for cos 2a, depending upon what you want, you can use any one of the three formulas. Again, fairness. So if we have done sin, if we have done cos, we better do tan as well. So what the formula for tan of a plus b? Tan of a plus b is tan a plus tan b over 1 minus tan a tan b. What happens when you put a as b? I get tan 2a equal to tan a plus tan a is 2 tan a over 1 minus tan a times tan a is tan squared. So that is the formula for tan 2a. Some of you are thinking, why did I decide to do A-level maths? If I had known there are going to be so many formulae to remember, I would never have joined or opted to do A-level maths. I would have given up. I enjoy maths, yes, but too many formulae, I can't remember. It bugs me. No worry, you don't have to remember all these formulae. Remember how I derived them. Sin of a plus b is sin a cos b plus cos a sin b, put a equal to b. That formula sin of a plus b is in your formula book. So you can use that formula and write this formula whenever you want in the exam. That way you have less formulae to remember here. Yeah? Same way for cos, same way for tan. Then you're wondering, sir, why did you give these two? When we do integration later, depending upon the question, I might need cos 2a only in terms of sin, or I might need cos 2a only in terms of cos. Suppose I had an equation, something like this, you see. I'm going to take that equation later. Suppose I had cos 2a, 2 cos 2a minus 3 sin a plus 1 equal to 0, something like that. I can't solve this because I got a cos 2a and a sin a. But if I write cos 2a as 1 minus 2 sin squared a, I will get a quadratic in sin. Then I will not use that, I will use that. Whereas I could have had cos a minus cos 2a equal to 3 equal to 3 over 4. Once again, I can write cos 2a as that. I can write cos 2a as that. I can write cos 2a as that. But I have a cos a, so I will use everything in terms of cos. When you want to prove the formula for sin 3a and cos 3a, you will require those. Okay, that's why again you prove using the formula book for cos of a plus b. Write down that formula. Then you unfortunately you have to remember sin squared plus cos squared is 1. Then you can deduce the other two formulae. Okay, but then comes the question: what if it were to be? We're done for 3a. What is sin 4a? What is tan 6a? What is cos 3a? Yeah, I can't have a formula for double angle formula, so quadruple angle formula, triple angle formula, 6a angle formula for 6a. Like that, there will be millions and millions and millions, right? Then how many formulae? As it is, you are finding it difficult, or you're fed up of remembering the formula. I'm increasing your problem. Or let me make life more complicated. Cot of 3 theta over 2 or sine of 2 theta over 5. How the hell are you going to get I'm sorry, I shouldn't be using that. How am I going to get formula for each one of these? Not to worry, don't worry. What do they say? Keep calm. Drink coffee. You see that mug my student had given me? Keep calm. I'm a maths teacher, so don't worry. Let's take sin 4a. To understand this formula, remember, you can apply this formula to any angle. Alright? It's only that, for example, if you have 2a, it becomes a and a. This sine, this 2, that sine, that cos does not change. Sin 4a is not 4. Only the angle changes in the ratio 2 to 1. Nothing else changes. So if I have sin 4a, 2a is 4a, that means everything is 2. So the 2 remains the same, the sine remains the same, the cos remains the same. 2a became a, 4a becomes 2a. 2a became a, 4a becomes 2a. So sin 4a formula is 2 sin 2a cos 2a, not 4 sin. Generally students think because 2a had a 2, 4a will have a 4, 6a will have a 6. No. It's only the angle that change in the ratio 2 to 1. Other functions, other constants remain the same. Okay, I've done that. Now what about tan 6a? What is the formula for tan 2a? 2 tan a over 1 minus tan squared a. So to get 6a, it is 3a times 2, yeah? So it's double of 3a. So wherever you have a, you write 3a. The numbers do not change. The ratios do not change. It's only the angle that changes in the ratio 1:2. With that, I did tan 6a. Of course, there is another formula for cos 3a. Suppose I have cos 3a. Cos 3a, look, let's make it 3 theta. Cos 3 theta, 2a is 3 theta. So a is half of 3 theta, or 3 theta over 2. So the cos squared does not change, the sine squared does not change, the minus does not change. This becomes half. That becomes half. Or the 2 does not change, the cos squared does not change, the minus 1 does not change, 1 does not change, minus 2 does not change, sine squared does not change. So that is 3 theta over 2, because half of that, 3 theta over 2. You get the hang of it? So whenever you apply double angle formula for another angle, the numbers like 2, -1, cos, sine, they don't change. The only thing that changes is the angle in the ratio 2 to 1. Okay? Oh, I don't want to do this. Let's do this. I can't get cot, so I do tan. So tan 3 theta over 2 equal to, look, your 2a is 3 theta over 2. So your a is, what's it? Yeah, come on. 3 theta over 2 divided by 2. 3 theta, no. 3 theta divided by 4. So it is 2 tan 3 theta over 4 divided by 1 minus tan squared 3 theta over 4. That is tan. So what is cot 3 theta over 2? Will be 1 minus tan squared 3 theta over 4 over 2 tan 3 theta over 4. And a math teacher like me might decide, no, I want in terms of cot. Then you convert it to 1 over cot squared, 1 over cot, simplify, I get, I think when you do this, I get cot squared 3 theta over 4 minus 1 over 2 cot 3 theta over 4. I will leave it to you to figure out by converting tan squared to 1 over cot squared. Okay? So, to conclude this, I will write the half angle. Normally, half angle formulae and double angle formulae are the most common ones. So, I've written the double angle formulae. So, I will build the half angle formula. As I said, the handout will have all the formulae, don't worry. So, sine theta. 2a is theta, so a is half theta. 2 sine half theta cos half theta. Get it? Cos theta equal to 2a is theta, a is half theta. Cos squared theta over 2 minus sine squared theta over 2, or 2 cos squared theta over 2 minus 1, or 1 minus 2 sine squared theta over 2. Same way, you can write tan theta as 2 tan theta over 2 divided by 1 minus tan squared theta over 2. This especially, a common question will be finding the value of tan 22.5 degrees without using a calculator. Then you use a quadratic equation with this. We'll consider in the next lesson. So that's an introduction to double angles, and we'll spend next 2-3 lessons as usual. I proved the formula, identities. Now I will do simple questions. Then I will do identities. Then I will do equations. And then we'll look at what another aspect of trigonometry. Same story. Then we go to radian measure. Same story. Okay? Have a nice day. I'll see you in the next lesson if you come back. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.